Okay, video 2 for Unit 4, which is on the transformation. So we're on the back of your chart. This was just a reminder of the vocabulary word isometry. That means that the image is congruent to the pre-image. And that happens on translations, reflections, and rotations. But dilations are not isometric. So translations, reflections, and I'm going to run out of space, and rotations. So dilations are not, because they're not going to be congruent if they're a different size. So that's just a reminder of what the word isometry or isometric would be, to say that the shapes are isometric. Okay, combination of transformation. So what we're going to do now is put together more than just one transformation in a problem, and the order does matter. So the best thing to do is just go in the order that they're written. So for our example, we're going to rotate 90 degrees counterclockwise, then we're going to translate it. So first thing we're going to do is take this shape and rotate it 90 degrees counterclockwise. So if you remember how that affects our ordered pairs, if we start off with, we'll do this one first. This is 3, 4. So 3, 4. So we're going to reverse the x and the y's, and then the y is going to become negative. So when we switch this, our new point is going to be negative 4, 3. So we're going to switch them and then change that 4. So it's going to end up looking like this, which is negative 4, 3. So G prime is going to be negative 4, 3. So that's G prime. L is over 1 up 2, so our new point for L prime is going to be negative 2, 1. So that's going to be L prime. Q is for negative 1, so the new point for Q prime is going to be 1, 4. So over 1 and up 4. So that is Q prime. So here, there we go. All right, so there is our shape that's been rotated 90 degrees counterclockwise. All right, now what we're going to do is translate it. We're going to take this shape, we're going to go 4 spaces to the right and down 6. So I'm going to go 4 spaces right and then down 6. So 2, 4, 6. So this one right here is Q double prime, because this is our second transformation. So right here we're going to go to the right 4 and down 6. So G prime should be, or sorry, G double prime. We're going to take L, we're going to go to the right 4, and then we're going to go down 6. So L prime should be, or sorry, L double prime should be right here, but did I go over 4? Yes, I did. Did I go over 4? And 1, 2, 3, 4. So there we go. Okay. All right, so that is the end shape, that one right there. Okay, rotational symmetry. We did this really quickly one day. I think it might have even been after a test or a quiz, or probably a quiz because it was still in the same unit. But this is when we look at how many times a shape will land on top of itself in one full rotation. So in 360 degrees, we're trying to figure out how many times that shape will fall onto itself, like identical. And then we divide that number into 360, and that tells us that the degree of rotational symmetry. So to look at this, we started off with a star, and we did this one in class. So we can turn this 1, 2, 3, 4, 5 times. So we can turn a star 5 times. So in 360 degrees, a star will land on itself 5 times. And if we divide that out, we know that each turn is 72 degrees. So we say that there's 72 degree rotational symmetry. All right, this snowflake can turn 1, 2, 3, 4, 5, 6 times, so in 360 degrees we can turn that snowflake 6 times, which means its rotational symmetry is 60 degrees. This shape right here we can turn 3 times, so 360 divided by 3 means that its rotational symmetry is 120 degrees.